All right, so here,
Mm-hmm.
let's start from the beginning because we did not record. We had on gig Ethernet
Yes.
like this. Gig 1, I was connecting to gig 2 here. And as soon as
Mm-hmm.
you put that one, you see this will become green. Gig will become green and fast Ethernet will become red. It will become
Right.
red now. Fast Ethernet will become red. Wait and see. Gig will become
Mm-hmm.
green.
Mm-hmm.
Even
Okay.
on switch P, gig will become green. On switch P, both the ports will become
Mm-hmm.
green because the MAC address is smaller and the priority is a tie. First, it will check the
Mm-hmm.
priority because there is a tie in the
Yes.
priority. It is going to now
Mm-hmm.
see the MAC address, and you see the switch in the left, whose MAC address is bigger, is now blocking. That itself
Mm-hmm.
proves that switch A is not a
Mm-hmm.
root switch. Why? On a root switch,
Mm-hmm.
the ports will be in forwarding state.
Both both ports will be in forwarding
So
state.
when
Yeah.
I check the command show spanning tree, which we have not enabled, it is by default enabled, and you can see this is the priority, and this is the MAC address.
Mm-hmm.
Because this is a root
Mm-hmm.
switch,
Yeah.
the MAC address is same in this field as well as in this field.
Mm-hmm.
Whereas the other switch, if you see, the switch
Mm-hmm.
is not a root switch. So it says the root switch is connected on
Mm-hmm.
0/1. Root switch is connected on 0/1.
Mm-hmm.
Where is 0/1? This is
0
0/1,
slash 1. Mm-hmm.
which means this is a root port. You see, it's a root port.
Mm-hmm.
The reason why this
Yes.
is called as root port
Root
is
port
this is
and
the one
root
which
switch is connected
communicates
on
to the root port. The
0
other
1.
port
Yeah.
is a
Mm-hmm.
blocking port. Hmm.
Root.
Now,
Because
why
it is going to
G01 is
communicate with the
elected
root
as a
switch
root port?
on the with the
Because
root
the
port. Mm-hmm.
cost is 4. For 100 gig link, the cost is 4. Sorry,
Yes.
for 1 gig, which means
Yes.
1000 meg, cost is 4.
Mm.
How did you get this 4? It's
1
a
gig.
predefined standard cost
Yes.
for spanning tree. So we are not going to do those calculations.
Predefined. Yeah.
It is unnecessary for us. It's an industry
Mm-hmm.
standard. And if it is 100 meg, the cost is 19.
Mm-hmm.
Now, because of the low cost, gig Ethernet
Mm-hmm.
is forwarding and fast Ethernet 0/1 is
Mm-hmm.
blocking. Now, what is our next scenario is when I delete this
Mm-hmm.
wire,
Blocking. Yes.
when I delete this wire, the blocking of F01 should automatically
Mm-hmm.
turn to forwarding. See, every 2 seconds it sends the hello, means BPDO.
Mm-hmm.
If a hello is not coming for 15 seconds,
Mm-hmm.
it understands that something is wrong.
Yes.
Okay, now
What?
you see, this is in a learning
15
state.
second. Okay. Mm-hmm.
First,
Yes.
now it is in forwarding state. So it is
Mm-hmm.
now it is green. You can see the green now. We'll talk about that.
Mm-hmm.
We'll talk about that. Still not fully
Okay.
ready. As of now, I want to say that it's not fully ready.
Mm-hmm. So learning state means like it still
Now,
not understand. Yeah. Mm-hmm.
we are going to add
Okay. Okay.
another link whose cost is 19.
Okay.
We need to understand if the cost is same. We need to understand if the cost is same. What based on what blocking port will be elected.
Mm-hmm. Same cost.
For that, you see, I'm randomly picking one number 19
Mm-hmm.
here, and in here I'm putting 6. All right.
Mm-hmm.
So what we are going to do is we are going to discuss and then we'll go and verify. We really do not know which one is blocking, which one is forwarding. right now. Okay.
Mhm.
Now,
Mhm.
you know very well that this is going to be the root port,
Okay.
root switch. And this will be what? Forwarding.
Mhm. Right now, yes.
Designated to forwarding. Both the ports will be designated to forwarding. Now,
Yeah. Root switch, yeah.
here I have fast Ethernet, here I have fast Ethernet.
Forwarding, yes.
The cost is same. If the cost is lower, then lower will be root port. But here in our
Mhm.
case, the cost is same. What it is going to do? What it will do,
Yes.
it will say from root switch. From root switch, when the BPDU
Mhm.
is received, what is the port
Okay.
cost? Not STP cost. Port cost. What is
Mhm.
port cost? If this port is
Mhm.
F0/24, the port cost will be
Mhm.
128.24.
Mhm.
What will be the cost here?
Okay. Okay.
128.6. You want to see? Hmm.
Mhm.
That is the STP cost.
Okay. Okay.
This is port cost.
Okay. Sir,
So now
earlier cost 19,
we got
19 stands for
128.6
speed. STP cost.
coming in
Okay.
BPDU.
Mhm.
I want to show you that. Go to switch B.
Port cost, yeah.
You see? 128.6, 128.24.
Mhm.
For port number 6, it is
Mhm.
6. For 20 for 24th port, it is 24.
Yeah.
That is also called as port priority. What the
24.
neighbor
Yeah.
will see. Neighbor will see
Port
for switch A. Switch A is the neighbor of
1. Yeah.
switch B.
120.6. Yeah.
For switch A, the incoming port cost is 128.24
Mhm.
here. Here 128.6,
Yes.
which is lower. Spanning tree likes this port because
Mhm.
it is receiving lower port cost. See, here the port cost will be
Yes.
128.1 only.
6.
It won't consider that. It will see only the
128.6.
incoming. Don't forget, incoming.
Yes. Yeah.
In which port the incoming
Smaller.
is lower? In 19 port,
Mhm.
incoming is lower.
Yes.
So this will be a root port again. Let's go and verify that.
Yes.
Look at this. It's green.
Mm.
You see, 19 is
Yeah.
because the incoming from there
Mhm.
here comes.
Mhm.
You don't see this local priority. It will see only the neighbor's priority. The incoming
Mhm.
from the root switch.
Yeah.
This is F06. Which means 128.6. That is
Mhm.
coming
Mhm.
here. Here 128.24 is coming. That's why it is blocking here. You
Mhm.
understood?
Mhm. 6. Mhm. Mhm. Uh, Sir, one more. Yeah, okay, I will summarize. Can we go back to the picture? Let me summarize. So, yeah, so we have the same cost link came now, and now we have to understand which link will be considered as block, which port. So we'll be choosing the earlier we are choosing the STP cost. Now we have to choose the port cost. Port cost of in switch B, port
Yeah.
cost
It will
of each
consider
port will be
F0/19
128.24 and 128.6.
as the
So
root
the
port because
neighbor of this switch B, which
128.6,
is
the
switch
incoming
A,
on that
it
port
can
is
see as incoming as
preferred, smaller.
128.24 and 128.6. So
Okay, now
128.6 is smaller, so it will consider
I'm
128.6
going
as the
to
uh,
disconnect these
mm,
cables And you're going to give me the reason why
Yes.
the blocking, okay?
Root port
So I'm going to disconnect this
incoming
wire, disconnect this
smaller.
wire. I'm going to put
Yeah.
different
Yes. Got it.
port, different, let's see. Here I'm just putting 10 randomly, some number 1, and again here I'm putting 6, and here I'm going to put 15. Now, according to what you learned, you need to tell me where will be the block. From the beginning, you think, okay, which switch will be the root switch? Okay, there is no change in that. Okay, this is the root switch. Now, will these two ports, okay, both are designated to forward. Okay, now the cost is same from here to reach
Where
the root switch.
again?
So it cannot
Yeah.
determine based on the cost.
Yeah. Switch B will be the
Now
root
you
switch.
tell me.
Yeah. There is no change in that. Both are in forwarding. Forwarding. Designated to forwarding.
No, no, no. It will make 10 F0/10 as a root port because of the incoming is
Cost. Yeah.
128.1.
So
Now let us go
now
and
it
check
has
it.
to
So you are saying
it
that
has
the
to check in
blocking will be
switch
on
A.
06, isn't
Incoming
it?
is
Let's go
128.15 and
and see.
128.1.
Is there?
So it will
Let's
choose
go and verify.
128.1 as the root port.
Alternate link
Yeah,
means,
it has
if
to
the that link goes down, then this is an alternate. It's a backup.
128.1, correct.
Yes,
So
standby. It's blocking.
yes,
So
F0,
you
yeah,
see,
correct.
spanning tree automatically prevents loop.
Yes, perfect. Yeah.
We did not do any
Okay.
configuration.
Switch A shows spanning tree. 016.
Oh,
LTN means role
okay.
is LTN
Now let's connect another wire.
alternate.
I'm going to connect the third wire.
Okay, okay, backup. Standby, right? Okay. Okay.
Now
Yeah, it
among
is
these
blocked. Yeah,
three,
correct.
it needs to find the blocking.
Mm-hmm.
Oh, come on.
Yeah, correct. We don't need to
Okay,
do.
it is
We
8
don't
and
need to touch
18.
it also, right? It's already up and running.
Additionally, I have here. Oh, right. Oh, funny. Okay. Additionally, I have 0/18, 0/8. Tell me which will be forwarding, which all will be blocking. On the root switch, as usual, this is designated to forward.
Yeah.
Correct.
So
So this is going to be a root port. Let's go and verify.
forwarding.
Switch
So
A
yeah.
again.
Yes, all are for. I mean, all port are forward. And in the switch
Yeah.
A,
10 is
switch A, we
block
are looking for
as
the
usual forwarding because of the lower
128.15,
incoming cost,
128.1,
incoming port
and
cost.
128.18.
The other two are blocking.
Right.
So I
So
told you,
as
even if you have
smaller is
100 links,
128.1. So it will
only one
choose
will be forwarding.
A0/10 as the root port,
Yeah, I told you,
and
right?
other two links will be blocked
Even if you have 100 link, only one will be forwarding.
root port. Yes, yes.
All other will be blocking. Now, let us change the scenario.
Yes, yes. Mm-hmm. Sorry. Sorry, what was that? only one will be forwarding, correct? Because because of this. Yeah.
Now the cost is going to be same, no? Because everywhere fast internet. Okay. Now let us discuss before it turns green. I'll take a snapshot. Okay. Sorry. I also want to know the MAC address of this. I'll call this switch as host name switch C. Okay. And I would like to copy the MAC address.
Now loop is there, yeah.
The MAC address is now this is going to be interesting. See, you already see where it is blocking, but let us see how it is blocking there, why it is blocking. Okay. Now, when you compare the MAC address, the lowest MAC address is this. Why? You see 9 here. Here you see C. 9 is smaller than C. 9 after 9 is A in hexadecimal, which is called 10, and then B, which is called 11, and then C, which is called 12. So here it is only 9. Sorry, here it is only 9, whereas here it is 12. Yeah, so 9 is smaller.
Yeah.
So this switch is elected as the root switch as usual. No change. So this will be forwarding, this will be forwarding. Now, both the switches will see which path is cheaper. Which path is cheaper to reach the root switch? For switch C, going like this is cheaper, only 19. If it goes like this, what will be the cost?
Yeah.
It will be more, 19 plus 19, which is more than 36. 38. It's too much.
Yeah.
So it will make this as the root port forwarding. You understood?
Yes, correct.
Because the cost going like this is cheaper. Yeah. Every switch other than switch B is a root switch. Other than switch B, all other switches will try to find a best path, cheap cost path to reach the root switch. This is cheaper, 19. Likewise, for this switch, this is cheaper. So this will be a root port forwarding.
Sir, one more time.
This is also root port forwarding. You understood why they are root port? Because that is the port that talks to the root switch.
From which perspective you are switch C, right? Okay. Switch
see,
C,
somewhere block should be there, otherwise loop will happen.
To C.
And that somewhere cannot be here, cannot be here, cannot be here, cannot be here. Here it cannot be because it's a root switch. Here it cannot be because this is the cheapest cost port to reach the root switch. Here it cannot be again cheapest cost port to reach the root switch. So blocking may happen either here or here. Now where will it block? For this, what it will? No. Only when we have two links like this, you have a tie. 1919. Here you don't have the tie. Now what it will do, it will compare their MAC address. It will compare their priority. Priority here also 32768.
Yes.
It will compare the MAC address. Spanning tree likes small, isn't it? So it will say here this MAC address is smaller than this. So I'm going to make this as the designated forwarding port. It's not a root port, it is a designated forwarding port.
Again, one
And
port
this will be
cost
the
we can consider, right?
alternate block. You got it?
Oh, okay, same cost. Okay.
Now, do you have a packet tracer? Do it and see now and let me know. Ask your doubts.
Okay.
Connect 3 switch like this and see what we have learned is there matching. Take 10 minutes. I'll wait. What if I want this to be a root switch? I need to change the priority. Let me show you how to change the priority to 0. When I change the priority to 0, what do we expect? Let us first of all discuss that.
Yeah.
When I change that to be the priority to be
Block.
0, what all the changes we are expecting? As soon as I change this as a 0 priority, the BPDU that is running everywhere
Yes, I have.
will alert other switches that, hey, someone is superior, meaning what? Someone is a winner. He has got lower priority. So no more we are heroes. Another big hero has come.
Okay.
So this is going to become a root switch, isn't it? Because the priority is 0. And now this will be the forwarding designated port. This will also be forwarding designated port. So it won't block. Now this switch will try to find the cheap path, cheap cost path, and this will be the root port. Agree. Likewise, this will also be a root port. Agree. Okay.
Priority.
Now blocking may happen here or here. Where it will happen? It will compare the MAC address. Again, this MAC address is bigger. He don't like big. He likes small. So this will be the designated forward. This will be the blocking. Shall we do and see? Are you ready? Okay. Now how to change the priority? I'll go to this switch. And in the global configuration mode, spanning tree for VLAN 1. We are using only VLAN 1 right now, isn't it?
Forwarding designated.
Priority 0.
Yes.
That's it. Now you see, I change the priority to 0.
Road body. Agree.
Did you note the command? Note down the command.
MAC address.
Now, after you see that, you see the priority is 0.
Blocking.
Plus VLAN number. What is the priority now? Total 1.
Yeah.
Now, this has become a root switch already. And I told you, this will not block. Right now it is in learning state. Wait some time, it will become forwarding. See, both are forwarding. As we expect, as we expected, this is already doing what we expected. Now, let us go and see whether this guy is doing as per expectation. 11 should be designated forward. Yeah?
VLAN 1 priority 0.
Show spanning tree. Yeah, 11 is designated forward. 1 is a root port, you see? 1 is a root port. 11 is designated forward. So that is exactly what we expect. Now let's go to the other switch. What do we expect from here? According to this diagram, 13 should be in blocking. Let's go. Show spanning tree. 13 is in blocking. That's it. Interesting, right? Automatic everything. When you change the root switch, all the
Mm-hmm.
story changes everywhere because the other switches
Mm-hmm.
know that
Yeah.
the switch is coming with a higher, so lower priority. The BPDUs, make all other switches know that there is a change. The BPDUs,
Mm-hmm.
the BPDUs are very powerful.
Mm-hmm.
Immediately it goes and informs all of the switches.
Expected. Yes.
Okay. Now,
Mm-hmm. Mm-hmm. Yeah. Yes. Mm-hmm. Yes. Mm-hmm. 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 PPTs. Yeah. Mm-hmm.